Hello, today we're covering Chapter 15, Virtualization and Cloud Computing. This is for the Network Plus exam. Virtualization and Cloud Computing, this is kind of where virtualization is kind of mainstream today. A lot of companies use it. You're going to find it used in pretty much every large and medium-sized organization. And cloud computing is just really just taken off in all areas of computing. So this chapter, while it's a short chapter, is an important one for your future if you're going to stay in the network area. So what is virtualization? The technical definition is the process of using specialized software to create an environment that imitates all of the hardware and software found in a physical computer. In reality, it's a piece of software, it's called the hypervisor, that will better utilize the CPU, memory, and hard disk of a machine. So instead of running a single physical server that does a single physical task, we can now run multiple servers on this host. So just a little history on computing in the Intel platform. You go back when servers really started in the 80s, 90s, early 2000s. A server did pretty much one job. If you wanted a file server, you bought a file server. A lot of disk space, not too much RAM, not a very powerful CPU, and you served out files. If you wanted a database server, you might want more RAM, a little bit more processing power, and depending on how size the database, your hard drive varied. But there was a lot of wasted capacity in these systems. That file server I was talking about, even though it didn't have a very powerful CPU, it probably only ran 30 or 40% utilized on a file server. RAM may not have been used very much at all. Hard disk was the big thing on a file server, but you just had a lot of wasted resources there. So in the late 90s, early 2000s, company came along and said, hey, we can take this, write this application called this hypervisor, bolt it onto figuratively bolt it onto a server, and then under that run guest operating systems. And as far as the hardware was concerned, they were a full-fledged server. But they're sharing the CPU, they're sharing the RAM, and they're sharing hard disk. And that became a virtualized environment. So the server that we have here isn't called a server anymore, it's called a host. The operating systems that are running under these are called guests. So, and they're full-fledged operating systems. It's a full-fledged Windows 2019 server. It's a full-fledged Linux version 7 server. It's not a some kind of bolted down system. It's a full-fledged operating system. So our host, it's going to contain one computer in this scenario. It's going to have CPU, RAM, disk space, and networking all housed, and all the virtual servers will share all of those resources. Our guests, they're going to be the virtual servers running on the host. And the hypervisor is software that manages all the hosts, its resources, RAM, hard drive, CPU, and it splits that time up among all the systems. So when one computer needs a CPU and the other computer needs it, that hypervisor is the one that manages that, how that process happens. Within the hypervisor, it can also give us a virtual BIOS. So you can actually see these things post when they boot. A virtualized computer takes commands, and they pass those commands from the CPU to the hardware. There's no conversion. So if your server is running on an Intel platform, the operating systems have to be Intel based. If they're running Motorola server CPUs, they have to be Motorola based. There's no conversion, so you can't run a Sony PlayStation as a virtual guest in a virtualized environment. And in emulation, The software will convert commands to and from entirely different platforms. So if we're going to emulate something, we can very well run a Sony PlayStation on an Intel platform. So what are some of the benefits of virtualization? Let's start with power savings. Keep in mind, these systems are pretty beefy, and it's not unusual to see a physical server run 20 or 30 guest operating systems. If I were to break those 30 guests out, that would be 30 separate physical servers. That means 30 power supplies, maybe, depending on what size they are, maybe even up to 60 power supplies, RAM, CPU, etc. So power savings is huge. Hardware consolidation. Again, instead of having 30 servers, I can have one. System recovery. This is really cool. Within a virtual environment, you can actually take a snapshot of a guest operating system, and that's of its current state. So if something goes wrong, you can just roll back to that snapshot. That's really, really great when you have to restore something quickly. You don't have to go to a tape backup. You can just actually restore it from a snapshot. One nice benefits about this is if you're doing an upgrade to a piece of software, you take a snapshot of that guest operating system, you do the upgrade. If the upgrade fails, you can just roll back right to the point where that snapshot was done. System duplication. You can actually have a server that's in production, and we'll say there's a new version of software out there that you want to run. You don't have to build a new system. You can just simply take that existing production server, make a copy of it, change its IP address or whatever, a name, and then you can you've got a copy of it, do the upgrade on the server. And research. A lot of people will use virtual environments for research. Remember, the hypervisor manages the host. It manages commands from each guest, and it sends the appropriate commands from the VM host to the CPU and hardware. The three most common hypervisors we have are VMware ESXi. That's our industry leader. That's got the lion's share of the market. Microsoft Hyper-V. This comes built into Microsoft Server and Microsoft Windows servers and Windows 10. And Citrix Zen Server. This is based on an open source hypervisor called the Zen Project. When you're administrating your hypervisor, you do this through a client. You don't actually monitor your hypervisor directly. So VMware uses the vSphere client, and Hyper-V uses the Hyper-V manager. One of the nice things we have in the virtual environment is the ability to scale. It's very, very flexible. We can add resources very easily that affect the entire system. The other thing about this, if you do decide to buy another server, in many ways you can share other external resources. So we can scale quite rapidly in our virtual environment. We can add disks, hosts, or network capabilities to the existing host and physical areas. But like we talked about earlier, a lot of times we're not utilizing all that RAM and all that CPU. So if we have a guest that needs more RAM, it's just simply a matter of adding more RAM to that guest. And then to scale for disk resources, yes, you can take a server and keep adding more disks until it's full. And the storage area network is a way of sharing a large pool of disks with multiple hosts at the same time. So it looks something like this. You're going to have a couple of hosts, your network, and then this large SAN down here. This is your disk space here. And well, this is all virtualized up here. So we have some virtualization taking place in these two areas. Again, 4 VMs. They share the network. The SAN shares the disk space. In a case like this, our SAN can be expanded independent of the host servers. So we have three choices for storage area networks, or SANs. The first one's fiber channel. This is probably, at one time was a leading technology. We've since started to move more towards the iSCSI type systems. But fiber channel still has a large market share. It's got its own separate network from the data network. So you actually had the fiber channel network interface cards that went in your SAN server along with your other virtual hosts, and they connected to a fiber channel switch, and that became a storage area network. iSCSI, or the Internet Small Computer Systems Interface, also is pronounced iSCSI, uses the Ethernet network as its data transfer medium. So the same Ethernet switch you plug in your VM host is the same one you're going to plug in iSCSI to. And InfiniBand has its own network. It's separate from the data network. On this one, it's important to know that InfiniBand is a way to expand disks, and it's related to SAN technology. And like fiber channel, it has its own separate network from the network data. A network attached storage is a dedicated server that has its own file system, and that file system can be shared as an individual drive. So if you have a server out there that's connected to the network, Ethernet network, you have another workstation, we'll say, and that workstation needs an L drive. You can tell that workstation to connect to the NAS, or the network attached storage, and map that drive L to its system. And like virtual network storage and virtual CPUs, virtual guests, we have virtual networking. So again, we have a single host, and within that host we'll have two virtual machines, VM1 and VM2. Each VM has its own network interface card. There is a physical network interface card on the host, and logically within memory, these network interface cards attached to that physical network interface card, and that is trunked down to a network switch. Along with a virtual NIC, each host can have a virtual switch. The virtual switch will plug into the real network interface card, trunk that to your real switch, your Cisco switch, and from there you can connect to the rest of the network, workstations, storage, etc. Now you'll hear the term distributed switch within the virtual environment. The term distributed switch basically is going to give you the ability to manage all of the switches using your hypervisor. So you might have 3 or 4 physical hosts. You can simply manage how that switch operates in those 4 physical hosts using a distributed switch. And that switch may look like a single switch among 4 or 5 servers. Your host may also support other virtual devices such as routers and firewalls. Just a bunch of different things we can put in that hosted environment. Software-defined networking, or SDN, I should have had that out there, I'm sorry. SDN uses a network controller to manage all your virtual devices along with your physical network devices. So the software-defined networking is just, it controls servers, switches, routers, and also can help manage the logical devices. Cloud computing. Cloud computing is basically using the internet for its own, the internet servers for their processing power. There are 3 categories of cloud computing. The first one is software as a service. The second one is platform as a service. And finally, we have infrastructure as a service. For software as a service, a company is going to run software on the internet, We're all familiar with Gmail, those hosted email systems. That's a software as a service. Other examples might be Office 365 or Dropbox. Platform as a service was designed for developers and database administrators. In Platform as a Service, we give the programmers all the tools they need to build, deploy, and administer applications, but they don't ever have to touch a server. They go out there and they just run these, your programmers learn to run the virtual environment in that programming or Platform as a Service environment. Infrastructure as a Service, this is where we actually start to build virtual servers. So, and for cloud-based, we're going to give a company access to virtual hardware, virtual operating systems, network equipment, and maybe virtual switches and routers. Company can lease and configure this equipment to devices to meet the most demanding needs. A lot of times people will run servers on premises, but during winter months when demand increases, they may run or lease additional space on the internet to augment their storefronts. In this case, capacity can be procured and deployed very, very quickly in the SaaS environment or IaaS environment. If you need a new server, simply log into, say, Amazon or Azure, you tell it, go to the programming interface, you add a new server, RAM, hard disk specifications, and turn it over. Nice part about IaaS, it's relatively cheap compared to a server. A low-end server might run you $3,000-$4,000. A low-end IaaS device might run you just a few dollars a month. So we have three ways of delivering these models to an organization. In the public cloud, we actually lease these devices, or these servers, these resources, SaaS, PaaS, and IaaS, and we actually lease them from a company like Microsoft or IBM or CenturyLink or Google, and we run them as they may sit in our data center. Or if there is a software as a service, it's just an email server out there. We don't really pay much attention to it, it just always sends email. Anyone can purchase these services. They're cloud-based or public. Private cloud is when all those cloud features, the ability to spin up a server, the ability to add disk space and RAM fairly seamlessly, awesome on the internet. But you don't have to run it on the internet. You can program all those things and build it in your own garage or your own corporate headquarters and run it this way. The community cloud is similar to a private cloud, but it's run by several companies, not just one. And the last one's hybrid computing. In hybrid computing, we combine two or more of the offerings, so public cloud and private cloud or community cloud, and we combine them all into one cloud environment. In some cases, you may have a private cloud for your own application, but as you're starting to expand, you may have to expand into the public cloud. It may happen fairly quickly or a lot faster than you think it does.